Assalamualaikum warahmatullahi wabarakatuh. Okay, so this week we will continue on chapter 2.1.4, which is on level measurement. Okay, but before we go deeper into this chapter, I would like to briefly give the understanding for you about the process control and instrumentation. Maybe some of you cannot imagine what is the function of these courses. Okay, basically, in all plant, in all industries, we need to have this process control and instrumentation, because all the plant, all the big plant, we run in a auto mode, and also the process is a dynamic process. So in order to control the process, in order to get expectation, to meet the customer expectation, we have to control the process itself, right? So that's why this process control is very crucial. Basically, we can find this process control not just inside the plant, in our daily appliances also. We have like air conditioning system. In our toilet also we have a control system. It's a lever system inside the flushing tank. So actually process control is everywhere inside our surrounding area. And for your information, if you go to industry, normally the one who specialize in process control would be a process engineer. They will handle maintain the process of the plant. So this process engineer, the responsibility is very big, and also the pay is very high. If you don't have an interest to be a process engineer, you can also, with this process control also, you can also be an instrument engineer, application engineer, system engineer. So with this process control and instrumentation subject, you can go further in various fields. So for me, you can take this opportunity to really understand on each of the chapter inside this process control, because this process control is very interesting. Okay, so now let we move to chapter level measurement. Okay, so basically for this level measurement, the objective is to define the level measurement, describe the importance of level measurement, explain the operation of the blazer sensor and relationship between Archimedes principle and level. Next, explain the operation of fluid actuated sensor. Lastly, explain the operation of capacitance level sensor and relationship between capacitance and level. Okay, maybe maybe it's quite complicated for you to understand by reading all this objective. Okay, I will try to explain deeper in the next slide. So in this level measurement, we will cover on the introduction to level measurement, and we will cover on the measuring device, which is this blazer level sensor, fluid actuated sensor, capacitance sensor. Okay, what is level measurement first? Okay, a measurement of the height of the free surface of the liquid from a fixed datum or reference. That means we have tank here. I'm so sorry, my drawing pad is very sensitive, so I cannot draw straight. So basically this is datum, fixed reference. So the level is we measure the height from this free surface to certain height. So this is level. So why level is important? Because it can benefit in terms of economic, product quality, equipment, worker safety and reduce losses. I give one example in terms of safety. If we didn't control the level, if we didn't measure the level, sometimes the level can go up to the higher limits and cause flooding inside the tank. If the fluid inside the tank is a very corrosive tank or explosive material, when the level is increased beyond the limit, it can cause the pressure to increase and cause the tank to explode. So we have two types of level measurement here. We have direct and also inferential. So for direct level measurement, it is easy to use, simple. The purpose is for local indication. So for inferential, usually we use when remote reading is considered. So example of direct measurement, we have gauging glass, buoyancy type sensor, static pressure type level sensor. So gauging glass is the one that we have inside our control lab. We can also call it as a sight glass, or if you notice that inside our pilot plant also, near to the equipment we have a clear glass. So inside there we can see the liquid color, and also we have a scale to measure the level of the liquid inside the tank. So basically it's a gauging glass. Okay, so for buoyancy type sensor, this is the simple example of buoyancy type sensor is our flushing tank. So basically that sensor is floating. For example, like this, we have a liquid here. The sensor is floating at the top of the water level. So it will increase until certain limit. So until the maximum limit, and then if the water already achieve the maximum limit, it will cut the water that feed it into the system. Okay, next we have a static pressure type level sensor. So this type of level sensor measured directly through pressure transducer. So basically the level is measured by the pressure inside the tank for this static pressure type level sensor. Okay, next we move to inferential. So inferential we have two type, which is conductive type level sensor and also radiation type level sensor. So basically for conductive, the liquid, the mixture of the fluid inside the tank is a conductive fluid. So conductive change at electrode are used to measure the level. So we have a electrode here. So we have a minimum and maximum. So change of this conductivities, we can use the by measure the changes of the conductivities, we can know the level. Okay, so next is radiation type level sensor. So basically radiation type level sensor is used for dangerous, corrosive, high temperature, pressure process. So this antenna will transmit the radiations. So that radiation will be measured in term of time travel, or in term of the amount of the wave that go back to the receiver. So basically the method is where signal transmitted from transmitter will be absorbed by the sensor. So for this radiation we use a radioactive isotope such as Ca-137. It's located opposite to the detector where it will give the level reading. So now we move to level measuring device. So the function is to detect the level of substance that flow, including liquid, slurries, granular materials and powder. Okay, the substance to be measured can be inside a container or can be in its natural form, for example river or lake. So the level measurement device, we have two types, which is continuous level sensor and also point level sensor. So for continuous level sensor, they will measure level within specific range and determine the exact amount of substance in certain place. For the point level sensor, only indicate the substance is whether the substance is above or below sensing point. This one clear, right? So basically, now we move to the displacer level sensor. So the displacer is cylindrical in shape. So this one is displacer, cylindrical in shape. It have a constant cross-sectional area, made long short as required, made long or short as required. It depends on the process itself, whether big process or small process, big scale process or small scale process. So this displacer will be designed accordingly. So standard height for this displacer is 14 inch to 120 inch. So basically this displacer level sensor will use in applications such as knockout port, condensate drum, separator, flash vessel, storage vessel. So the basic operation, it uses the Archimedes principle to detect the liquid level by measuring the weight of this displacer. So basically, as the liquid level in here, so basically the process fluid will be fit inside here. So if the fluid is fed into the system and the level of this process fluid inside the process vessel increase, then this process fluid inside this sensor also will be increased. When the level of the process fluid increase, the displacer this displacer will experience a buoyant force. So the greater the buoyant force, make it the displacer become lighter. So the loss of weight of this displacer interpret the increase in level, and this signal will be transmit a proportional output signal. As liquid level decrease, the buoyant force on this displacer will be decreased, and the weight also increase. So which interpret as decreasing level. Okay. Now we move to fluid actuated sensor. So basically fluid actuated sensor is the one that the common example is the one we use inside the flushing tank, inside our bathroom, inside our toilet. So the sensor is used to measure liquid level in the tank, which is a fluid rests in the surface of liquid and follow the changing level of liquid So for this one, we use a concept of on-off controller. So this sensor is used to handle high temperature application, sometimes prove useful for close interface detection. So the basic operation is the float right on the process liquid surface. That means this is the liquid surface, right? So the float will be floating on top of the process liquid surface, on top the surface of the process liquid. So rising liquid level lift. So this float will increase when the process liquid increase in level. So sliding the attraction sleeve up inside the enclosing tube and into the magnetic field to actuate the electrical or pneumatic switch. So when this one increase, it can cause there is a magnetic field, and this signal will actuate the electrical or pneumatic switch. So when this liquid level goes down, this floating also will goes down. So drawing the attraction sleeve out of the magnetic field to deactivate the electrical. So cut off the electrical. When increase, it will turn on the switch. When decrease, it will turn off the switch. So now we move to capacitance sensor. So a capacitor consists of two plates separated from each other by an insulating material called dielectric. So this one is used for the corrosion, fluid, non-conductive tank, high temperature or pressure, splashing or bubble or foam, coating or build-up of salt or other process chemical. So basically, this capacitance sensor will be used under this type of condition. So the basic operation is one side of the process container. So the process container here act as a one plate, and immersion electrode here, this one electrode is used as the other. So the dielectric is either air or the material in the vessel, which is process fluid. This variation produce a change in capacitance. That means from here, this conductor and this process container cause a variations, produce a change in capacitance because of the dielectric in between. So dielectric in between here and here, process container and also electrode. So the change in capacitance is proportional to the level. So we can measure the level by this change in capacitance. Okay, now we move to the temperature measurement. So basically, the objective of this temperature measurement is first, differentiate between absolute and relative temperature scale. Next, transform a temperature reading among the Kelvin, Rankine, Celsius and Fahrenheit. Next, explain the operation, thermocouple and relationship between EMF and temperature. So EMF is also known as a voltage. Lastly, explain the operation of RTD and relationship between metal resistance and temperature. So RTD is resistant temperature detector. So under this pressure measurement, we cover the introduction to temperature measurement, and we have two types of measuring device, which is thermocouple and RTD just now is resistive temperature detector. Basically, in industry, normally we use thermocouple because it is quite simple, easy to install. So as per introduction, okay, temperature is a physical property of system that underlies the common notion of hot and cool. So when we dealing with the hot and cold fluid, we know it's a temperature. So temperature can be reported either in degree Celsius or degree Fahrenheit. We have Rankine, Kelvin. So on both the Celsius and Fahrenheit scale, the temperature at which water freeze and temperature at which water boil are used as a reference point. So as we know, for Celsius, freezing point is 0 degree Celsius. Boiling point is 100 degree Celsius. Meanwhile, for Fahrenheit scale, water freeze is 32 degree Fahrenheit. Water boil is 212 degree Fahrenheit. So on the Celsius scale, when we detect the temperature between freezing point and boiling point of water, we can get the value of 100 degree, right? So as compared to the Fahrenheit scale, it obtains slightly high value, which is 180. So that's mean the ratio for these two, Celsius and Fahrenheit, is 1 to 1.8. So now I move to relative scales. So a temperature scale in which measurement are amount that are more or less than a reference amount. So other measurement are made relative to this point. It have a both positive and negative number. So relative scale is degree Fahrenheit and also degree Celsius. So this one is relative scale. So from if we have a Rankine, so we need to convert to relative scale Fahrenheit. We can use this formula. If we have Kelvin, Rankine and Kelvin basically is a absolute scale. So if we have Kelvin, if we want to convert to degree Celsius, like we already know, we need to minus with this 273.15. So if we have degree Celsius and want to convert to degree Fahrenheit, okay, we need to times with the ratio just now, and also plus 32. It's a reference point for the freezing point. Okay, now we move to absolute scale, having absolute 0 as the lowest temperature. So as we know that Kelvin scale is the absolute temperature because it detects the coldest temperature possible. So our 0 degree Celsius is equivalent to 273.15 Kelvin. So this is actually, if we compare to the pressure, this is like a gauge pressure. So absolute pressure is the coldest temperature of this Kelvin, which is 0K. Okay, so in order to convert from Rankine to Kelvin, you can use this formula. So this is we can see here in Celsius we have 0 degree Celsius and 273. So basically Celsius is a if pressure is a gauge pressure, Kelvin is a absolute pressure. But in here this is absolute scale, this is a relative scale. Also this one. So now I move to our first device, which is thermocouple. So basically the configuration of this thermocouple is very simple. It consists of a pair of wire of different metal type. So this junction have a different metal type. This junction also different metal type. So we have hot part and also cold part here. Hot junction and cold junction. Okay, the basic operation, the heating the measuring junction of the thermocouple produce a voltage. Okay, so the difference between two voltage, so here this junction and this junction, the difference in two voltage is proportionate to the difference in temperature. The amount of current that we produce is depend on the temperature difference between the measurement and reference junction, the characteristic of the two metal used and the characteristic of the attached circuit. So basically, if we heated this part, it will cause the voltage to increase. So the difference this part of the voltage is constant. So when there is a increase of voltage here, there is a voltage difference between these two junctions. So by calculate the voltage difference by measuring the voltage difference, we can know the temperature difference inside here. So there is a few type of thermocouple. We have a type J, T, K, E, S, R. So each type of these thermocouple have different material and different temperature range. So it's depend on the usage and the suitability of the process that we want to measure. So next type of sensor, temperature sensor, is resistive temperature detector, which is RTD. So this RTD is dealing with the resistance. For your information, there is a relationship between the resistance and also temperature. Basically, resistance is a temperature dependent. So when the temperature increase, the resistance increase. Later on, I will show you a video about this relationship so that you can get more understanding on this working principle. So basically, for this resistance and temperature relationship, you can use this formula. Okay. So temperature sensor element is a thin wire coil. So inside this RTD, we have a thin wire coil, normally nickel or platinum. So it depends. If that RTD use a platinum, you can use this constant put inside the formula to calculate the resistance of the detector. So basically, for the platinum, the temperature range is between negative 100 degree to 650 degree. Meanwhile, for nickel, is from negative 180 to 300 degrees Celsius. So basically, for your information, nickel type RTD is cheaper as compared to the platinum because it have lesser linearity. So RTD sensor, its work based on the Wheatstone bridge signal modifier to change the resistance to standard voltage. So the operation of RTD basically, like what I mentioned before, when the temperature increase, T increase, resistance increase. So this RTD will be installed inside the process vessel. So when the temperature inside the process vessel increase, the RTD will detect the resistance increase. So we cannot define, basically for the measuring device, we will depending on the voltage, right? So that's why this RTD will be connected with the Wheatstone bridge so that we can get the voltage difference. Basically, this circuit use the concept V equal to IR. So if this R increase, so voltage also increase. So with the reading of the difference of the voltage, we can know the temperature difference inside the process vessel itself. Okay, so for this video I will stop until here. I will continue on the next video for the pH measurement. Thank you.